Hey guys, welcome back to my channel. As you know, we're continuing with the playlist for IGCSE Edexcel Maths A higher topic questions. Today we're going to do volume and surface area. I'm going to make a separate video for the basic questions for volume and surface area, where they're asking direct questions like find the area or surface area of a cuboid, sphere, cylinder, a pyramid, or a cone. And then there's a separate video where we see the more complicated questions where they've combined the cones and spheres, then spheres with cylinders, spheres with pyramids, where they're asking you to find the area of the frustum or the volume of the frustum, questions like that. If you're someone who's struggling with some other topic, you can check out the playlist above, because in this playlist, you will find several videos and each video is on a different topic using exam questions 2018 onwards. And I also have a separate playlist for the past papers. And in that playlist, you can access the latest past papers as well, like the May, June 2025 and the 2024 ones as well. So let's start with this one and see how easy or difficult these questions are. So it says the diagram shows a cuboid. They have given us the dimensions of the cuboid as 3x, y, and 2x. The volume of the cuboid is given as 1014 centimeter cube. The total surface area of the cuboid is 8 centimeter square. We have to show that A equals to 12x square plus 1690 over x. You must show all your stages of working. So in these type of questions, I strongly recommend that you show all of your working, because the question also clearly identifies that show all stages of working. I know some kids just, I don't know, do this in the calculator or do it mentally and just write the final answer and just say that, oh, this is the equation. You will not get any marks. When it says show all the stages of your working, you have to show the stages of working. You cannot just randomly jump up to the answer. So volume formula for a cuboid is length times width times height. So that's going to be 1014 equals to 3x multiplied by y multiplied by 2x. That equals to 6x squared y. If you look at the equation is just in terms of x, which means we need to make y the subject of this one. That gives us 1014 over 6x squared. We can simplify it. 1014 can probably be divided by 6, which gives us 169. So 169 over x squared is your expression for y. Now we're going to create an equation for the total surface area of the cuboid. So that's the sum of all of the surfaces of the cuboid. So we have 2x times y times 2, because they're two faces for the same dimensions, plus 3x times y times 2, and then plus 3x times 2x times 2. Now we have to substitute y with 169 over x squared and then simplify this equation to create the same one as given the question. So I'm going to move this over here. So that's 4x times y is 169 over x squared plus 6x times 169 over x squared and then plus 12x squared. That's going to be, so 4 times 169 is 676 over x. 6 times 169 is 1014 over x and then plus 12x squared. So you can combine the fractions. So 1014 plus 676 is 1690 over x and then plus 12x squared as it is. This is exactly the same as the equation given the question. So that's your answer. So for the cuboid, the formula is very straightforward. For the volume, you multiply all the dimensions of the shape, length times width times height. And for the surface area, you find the area of all of the faces and add it up. Then it says, here's a solid cylinder. The radius of the cylinder is 8 centimeters. The height is h centimeters. And the volume is given as 3,892 centimeter cube. We have to work out the value of h. Again, very direct. You have to know the formula for the volume of cylinder, which is pi r square h. we have the volume 3892 equals to pi times the radius is 8, so 8 squared, and then times the height. 3892 is divided by 64 pi. So we plug this in the calculator. That gives us 19.4 centimeters as the height. That's your answer. So very three easy marks, nothing complicated over here. Then it says, given that the surface area of a sphere is 49 pi centimeters square, find the volume of the sphere. Give your answer correct to the nearest integer. So surface area of a sphere is 4 pi r square. And volume of a sphere is 4 over 3 pi r cube. So we know that the surface area is 49 pi. That equals to 4 pi r square. 49 pi divided by 4 pi equals to r square. So the pi's get cancelled out, and 49 divided by 4 is 12.25. Now we square root both sides to find the value of the radius. So root of 12.25 is 3.5 centimeters. That's your radius. So now we can easily find the volume because the only unknown value in the volume formula is the radius. 4 over 3 pi times 3.5 cube. Plug that in the calculator. 4 times 3.5 cube times pi divided by 3. That's giving us 179.59 centimeter cube. We want the answer correct to the nearest integer. That's going to be 180 centimeter cube. That's your answer. Then it says a cylinder has a diameter of 14 centimeters and height 20 centimeters. Work out the volume of the cylinder, giving your answer correct to three significant figures. So keyword over here is that the diameter is 14, not the radius. A lot of kids make this mistake that they write 14 as a radius, even though it's the diameter in this case. Radius is going to be the diameter divided by 2. So that's 14 over 2, and that's 7 centimeters. So volume is going to be pi r square h. Pi times 7 squared times 20, which is going to give us 3078.76 centimeter cube. They want the answer correct to three significant figures. So that's going to be 3080 centimeter cube. That's your answer. Then this diagram shows a solid cylinder with radius 3 meters. The volume of the cylinder is 72 pi meter cube. Calculate the total surface area of the cylinder, giving your answer correct to three significant figures. So we have the volume, which is 72 pi. So we can use the volume and the radius to figure out the height, and then use the height to figure out the total surface area of the cylinder. So 72 pi equals to pi times 3 square times the height. 72 pi divided by 9 pi, that's going to be 8 centimeters for the height. Now for the total surface area of a cylinder, the formula is 2 pi r square plus 2 pi r h. 2 pi r square is your top and bottom area added, and 2 pi r h is your curved surface area. So that's 2 pi times 3 squared plus 2 pi times 3 times 8. That is going to give us 207.35 centimeters square. And they want the answer correct to three significant figures. That's going to be 207 centimeters square. That's how you find the total surface area of the cylinder. Work out the volume of the prism, giving your answer correct to three significant figures. So for the volume of the prism, we multiply the cross-section area by the length of the prism. So this 15 is your length, and cross-section area is going to be this triangle. So for this, we need to find the area of the triangle, and for the area of the triangle, we need the height of the triangle, like the perpendicular height. We do have the slant height, which is 11.2. We have the base, which is 7.4. So as we know in a right angle triangle, if two lengths are given and we need to find the third one, we use Pythagoras. 11.2 squared equals to 7.4 squared plus x squared. X is your height over here. So 11.2 squared minus 7.4 squared equals to x squared. That gives us 70.68. Now we square root both sides, and that's going to be 8.41 centimeters. That's your height. So now volume is going to be 1 over 2 times 8.41 times the base 7.4, and then times the total length of the prism, which is 15. So that's going to give us 466.75. They want the answer correct to three significant figures, so 467 centimeter cube is the volume of this prism. Then this one, it says a diagram shows a solid triangular prism. Work out the total surface area of the triangular prism. So to work out the total surface area of the triangular prism, so to find the total surface area of the triangular prism, we need the area of all of the faces. So we have two triangles and three rectangles. So total surface area is going to be 2 times 1 over 2 times 4.8 times 3.6. This is the area of the two triangular faces plus 3.6 times 7, area of the base, plus 6 times 7, area of this top face, and then the area of the back face, that's going to be 4.8 times 7. So that's going to give us 118.08 centimeters square. They want the answer correct to three significant figures. That's going to be 118 centimeters square. That's the total surface area of the triangular prism. Then it says the diagram shows two water containers. One is a cuboid and one is a cylinder. The cuboid measures 35 by 28 by 20 centimeters. The surface of the water in the cuboid is 9 centimeters above the base of the cuboid. So that's the height of the water. The cylinder has a radius of 10 centimeters and height of 33 centimeters. The cylinder is completely full of water. Izzy is going to pour all the water from the cylinder in the cuboid. Show that the cuboid will not be completely full of water. So very simple. We find the volume of the cylinder first, which is going to be the volume of the water in the cylinder as well, since it's completely full. So pi times 10 squared times 33. That's going to give us 10,367.25 centimeter cube. Then we find volume of the cuboid, which is going to be 35 times 28 times 20, which equals 19,600 centimeter cube. They want us to show that the cuboid will not be completely full of water. So if you find the volume of the water in the cuboid, that's going to be 9 times 35 times 28. That equals 8,820 centimeter cube. So if we add the volume of the water in the cylinder and the volume of the water in the cuboid, let's see what that gives us. 10,367.25 plus 8,820. That equals 19,187.25 centimeter cube. Now clearly that's less than the volume of the cuboid. So yes, the cuboid will not be completely full of water. That's your answer. Then it says here's an empty pool in the shape of a cuboid. The width of the pool is 3 meters, the length of the pool is 12 meters, and then the top of the pool is 2.5 meters above the base of the pool. Jeb is going to put water in the pool. The level of the surface of the water will be 60 centimeters below the top of the pool. So this distance is going to be 60 centimeters. As you can see, the other measurements are in meters. So 60 centimeters in meters is 1 meter is 100 centimeters. So 1 centimeter is 1/100th of a meter. So that's going to be 0.6 meters. Water flows into the pool at 400 liters per minute. 1 meter cube is 1000 liters. How long will it take to fill the pool to 60 centimeters below the top of the pool? So first, let's subtract 0.6 from 2.5 to get the height of the water. So 2.5 minus 0.6, that gives us 1.9 meters. Volume of water is 1.9 times 3 times 12. That equals 68.4 meter cube. We have to find how long will it take to fill the pool to 60 centimeters. So basically, how long will it take for this amount of water to be filled in the pool? So water is flowing at 400 liters per minute. So currently water is flowing at 400 liters per minute. Let's convert the meter cube into liters first. So 1 meter cube is 1000 liters. So volume in liters is going to be 68.4 times 1000, which is 68400 liters. So if in 1 minute we're getting 400 liters in the pool, for 68,400, we'll divide 68,400 by 400, and that gives us 171 minutes. They want the answer for time in hours and minutes. So if we subtract 120 minutes from 171, that gives us 51 minutes. So that's 2 hours and 51 minutes. That is the time it takes for the pool to fill till 60 centimeters below the top of the pool. This is a diagram shows two solid toy bricks, brick A and brick B. Brick A is in a triangular prism of length 5 centimeters. The cross section of the brick A is an isosceles triangle with equal sides of length 6 centimeters. Brick B is half a cylinder of length 5 centimeters, and the semicircular cross section of brick B has a diameter of 6 centimeters. The volume of brick A is greater than the volume of brick B. How much greater? Give your answer correct to one decimal place. So for the volume of brick A, find the cross section, which is 1/2 times 6 because it's a triangle, and then times it by the total length, which is 5. That gives us 90 centimeter cube. Then for volume of B, it's half a cylinder, so pi r square h over 2. Diameter is 6, so radius is going to be 3. So pi times 3 square times 5 divided by 2. That gives us 70.68 centimeter cube. They said that the volume of brick A is greater than volume of brick B. How much greater? So difference of the two volumes. So that's going to be 90 minus 70.68, which is going to give us 19.32 centimeter cube. They want the answer correct to one decimal place. That's 19.3. Simple as that. This is a diagram shows a cuboid and a cylinder. The dimensions of the cuboid are x centimeters by 12 centimeters by 5 centimeters. The volume of the cuboid is 270 centimeter cube. The radius of the cylinder is x centimeters and the height of the cylinder is 2x centimeters. We have to work out the volume of the cylinder, giving your answer correct to the nearest whole number. So using the volume of the cuboid, we're going to figure out the value of x first. So 270 equals to x times 12 times 5. So 270 divided by 60, because 12 times 5 is x. That's going to give us 4.5 as the value of x. So the volume of cylinder, that's going to be pi r squared, so r is 4.5 times the height, which is 2 times 4.5. That's going to give us the one that's correct to the nearest whole number. So 572.5, that's going to be 573 centimeter cube. Change 1 meter cube to centimeter cube. 1 meter is 100 centimeters. So for 1 meter cube, we multiply 100 to itself 3 times. So that's going to be 1,000,000 centimeter cube. That's 1 meter cube in centimeter cube. And with that, we're done with the basic questions for volume and surface area. If you have any questions or confusions, please leave a comment below and I'll help you out. And if you understood everything, please like and subscribe, share this video with your friends, and don't forget to check out the other videos in this playlist. I'll be uploading separate videos for the cone and sphere questions, like which have the frustum and pyramids as well, like mixed with cylinders. And then I'll be uploading a separate video for like the mixture of volume with 3D trigonometry. So all of these questions will be divided into different videos so that whoever struggles with which area, they can just access that video and learn from their mistakes.